Okay, hello everyone. I'm Marvin Tan, and I'm your senior Alam YDD. I'm here to help you. So I'm making this video to show you an additional problem regarding URS or unrestricted variables. So let's make this larger. Okay. So try it on your own first, on a piece of paper, and pause the video and read it and try it yourself. Afterwards, you can watch this video. Alright, so I'll give you time to pause it. Alright, so pause the video. Okay. 3, 2, 1. Okay. Let's start. So, what you noticed in this video is it's not your typical class examples wherein they give you a specific value for the caps or for certain values in general. Like, for example, red blue gadget. They have, let's say, there's 500 of a certain supply of something. So it's less than or equal to 500 in that case. But in LTs, many times is they expect you to set it as a constant since it's not given. Like for example, in this example, salaries, a salary of a specific player, it's not given. So the profs, they expect you to add in the constant, let this be the salary of specific that. Alright, so that's what we're gonna do. Okay, let's start. So essentially, this is this yap. Sometimes that happens. Let's usually what I do is I already set it up. Constants, obj, and then constraints. Sometimes it's actually hard to get objective function at times, so you can jump straight to the cons. Sometimes you can jump straight to the constraints. If sometimes you don't really know for sure yet what the objective function is. It doesn't have to be dv's, constants, objective function, constraints. Sometimes you have to jump. And that's very common, especially when the LT questions, when they come out, it's very long. So dv, when you first read the problem, you see that he has to sign a number of players from number of guards, forwards, and centers. So that's clearly our dv. So let xi, I actually solved it already, so let me just copy paste since if not, this is going to take very long since there's a lot of constants. So yeah. Essentially that, okay? Then next is this. I'll show you my thought process, okay? Then within each position, all players are identical, meaning every guard has the same salary and expected performance contribution. Though this is the case, salaries and performance contributions differ across positions. So here we know that there's specific salary and performance contribution per type or per position. So it's basically not something we decide on but given to us, but we just don't know it. It just exists. So that's a constant. So it's, yeah, this one. Okay. So basically we're done with this. Now, the owner allows the team to exceed the salary cap, but doing so is expected to increase team performance proportionally. On the contrary, if the GM chooses to spend less than the salary cap, the expected team performance is proportionally lower. What we notice here is there's either it goes above the salary cap or below the salary cap. Basically, so there's a variable. We need a variable which is going to be our URS to show the difference between the total salary used up and the salary cap. So let's let y, which is a URS, be that one. It's the difference between the salary used up and salary cap. We must note that y here is a dependent variable, because basically the salary used up is fully dependent on our independent variables, which is xi. When it comes to dependent variables, you have to define it in your constraints. So let's actually do that first. Since this is a constant, oh, let's define it also. Yeah. The owner exceeds the salary cap, but it's not given. So it's also another constant. Let's call it cap equals salary cap set by owner. So let's define our first constraint, which is y equals, it's basically the difference between salary used up. Salary used up is basically xi times si. So it's basically summation, or sum of that one for all I. Okay. Minus, essentially, what do you minus again? Difference, oh yeah, salary cap, which we already defined. So we define the dependent variable. Define y. That's one. And then we must remember that this is a URS, right? So you have to make two new variables. Actually, yeah, let y, positive, equals number above salary cap. And then below salary cap. We'll use that later. For now, let's just use y since it's easier. For now, then we're gonna linearize it, right? Alright, so now what we do is essentially we continue on with the problem. So we already have this. So the goal is to maximize the linear estimate of the team's total expected performance, accounting for both. So that's what we want to, that's our z, essentially. It's equal to player contributions, which is, this one. It's the sum of xi times pi. And pi is the contribution per player. So basically, if you sign 4 players, you have to times it by the performance contribution, right? And then, we should also take note of the payroll effects. Payroll effect in this case is the deviation, which is y, times the effect per unit of deviation, which is bonus. So we should define the bonus. Let bonus equals payroll effect per unit deviation. Okay. So basically, it's gonna be bonus times y. So if your deviation is, let's say, 1, you have to times it by bonus, right? So let's say bonus 10. So it's 10 that affects your expected performance. So what we notice here, let's test it first. We don't know if it's plus or minus, right? Let's try with plus first. So let's say y is positive, right? So positive means it goes above the salary cap. And if it's above the salary cap, then there should be like it's actually bad in a way to go over the salary cap. So it means that the expectations must be higher, right? The owner's expectation. So it should not be the case that it improves our objective, it improves our z. So we make this minus. Okay, so basically, we're done with this. We defined our z. Then now, lastly, the GM must comply with league rules, including a minimum and maximum roster size. Okay, since it takes long, so I'll just Copy paste it here. Yeah, so basically we add constraints. It doesn't, I mean, add constants. It doesn't say what the max and min is. So yeah. Then now we have to, yeah, roster size constraint. So it's basically the sum of all xi's, which is a number of players. If you sum all of it, number of guards, forwards, and centers, it has to be greater than or equal to the min and less than or equal to max. So that's what I did here, essentially. And then now, lastly is, there's a minimum position specific requirement for guards, forwards, and centers. We should have like at least some number. And we don't know that number, so we make it a constant. Yeah, so minimum specific. So now essentially, for each of the guards, it should be higher than, greater than or equal to the minimum requirement, right? So that's what I did here. Greater or equal for all I. And lastly, NNC. X, since Y in this case is not really NNC-able, since it's a URS, right? Yeah, okay, greater than or equal to 0. So 4 is NNC. So as you know, what you have to do is basically essentially turn the URS into the positive and the negative, right? So we break it down into these two variables. So yeah, where y, yeah, note y equals so we have the, yeah, essentially this. And you must note if y is positive, then this will be positive and this will be 0. If let's say this is -3, then this will be 0 and 3. So essentially, one of them is 0, and now none of these two can be negative, right? So that's what we did here. And what you note is you still have to define y, the URS. So let's do it. Y equals this minus this. Define URS variable y. You have to replace all the y's by this, since you can't have the y, which is not NNC-able. Yeah, let me replace this by all the y's. Give me a second. Yeah, you should also put here. It's also, now this one's NNC. And then this is also NNC. Looking at the video, I saw that I forgot to actually do linearize it. So now, yeah, I added this for method 2. It's like this. So basically, that's it. Hopefully you learned something from this video, and thanks for watching. I'll also be sending this in PDF form or in a link.